here, then let's look at a few details about slope. Slope is a ratio of the change in y to the change in x. Whatever you may remember about ratios from the past couple of years, a ratio implies that you're going to have a fraction. It's also known as rise over run. When you're looking at it graphically, that way of describing it makes a little more sense and is often used. And when you write it in an equation, in a general form equation, m is the letter that all of those great mathematicians that came before us decided to use for slope. And then here is the formula for calculating slope. And if you see that, it says m, which stands for slope, equals, and there's your fraction. The numerator of that fraction is the change in y, which is found just by subtracting whatever the y values are. And the denominator of that fraction is found by subtracting the x's, and that's the change in x. This is the most common mistake in calculating slope, is people forget to put the change in y's on top and the change in x on bottom. So just remember it goes y over x. All right, let's look at a graph, and we're going to find the slope in this graph. Here are points that lie on the coordinate grids where the line goes through the corner of a box. Those are the points you want to use because you can count whole units when you use those points. So let's choose a couple of those and get counting. So I start there at 0, 2, and if I count up 3 units, I'm in line with the next point. And then I'm going to count over 1 unit. And so there my change in y, which is that vertical distance of plus 3, and my change in x, which is that horizontal distance of plus 1. You know, the y-axis runs up and down, the x-axis runs left and right. So your up and down change will go on top, hence your rise, and then your run will go in the denominator of your fraction. So I have my slope is equal to 3 over 1, and that simplifies to just 3. Now, you can have a simplified fraction, but you can also be left with a fraction like 1/2. You don't necessarily always end up with a whole number. So let's look at another point and see if when we choose it, we get the same thing. If I start at the very bottom point there at 0, -4, and count up to the very top point, which is at 2, 8, it looks like. If I do that, then I have gone up 12 units. Now, if I go across so that I can get back to the line, I go across 4 units. And when I calculate that slope, my change in y, the 12, over my change in x, the 4, I get that 12 over 4 still reduces to 3. So when I'm calculating slope, it does not matter which 2 points on the graph that I choose to use. They're all the same, giving all the same slope, as long as I choose points where it goes through whole number coordinates or the corner of the boxes there. And that won't, it does not matter which ones of those I choose. It should always simplify to the right, to the same thing, as long as you calculate your slope correctly. All right, and the reason that happens, if you look at the triangles that are made from the red lines and then the piece of the blue line that they intersect, those triangles would be similar. One is larger than the other, in this case by a scale factor of 4. So let's look at the next one, and we're going to choose a starting point. And, oh, sorry, the slope is 3. I forgot to tell you that. But anyway, we're going to choose a starting point. Here I chose to start at 2, 0, and we're going to go up until we're in line with another point. And we went up 2 units, and then we go to the left 1 unit. Now, going left is a negative direction. Up is positive, down is negative, left is negative, right is positive, just like the axes run. So now when I make my fraction, I have m, or slope, equals 2 over -1. That simplifies to -2. Again, I got a whole number here, but I could have gotten a fraction, and we will see some that give us fractions in a few minutes. So when I simplify this, I find out that the slope is -2. All right, let's look at a different way to find this from a table. And again, I'm going to be looking for the change in y over the change in x. So I'm going to look at the y column first. And I'm going to notice that from 2 to 7, I have to add 5. And from 1 to 2, I have to add 1. So if I'm looking at my change in y over my change in x, I get that my m equals 5 over 1. Well, I want to make sure that this table is linear and that continues. So from 7 to 12, I get 5, and from 2 to 3, I get 1. So 5 over 1 is still 5. But from 12 to 22, I get 10. But on the other side, I didn't go up by 1. I went from 3 to 5, so I went up by 2. And if I look at that ratio, my slope of my change in y to my change in x, that's 10 over 2, which still reduces to 5. So earlier in this unit, we always talked about that our y's and x's had to go up by the same amount each time. And that was before we had really looked at slope. And when you look at slope, if they don't go up by the same amount, then the amount that they go up by has to be proportional. So when I double 5 and make it 10, I have to double the 1 and make it 2. So that when I calculate that ratio, it will be the same. All right, let's look at the next table. From 2, let's look at the y column first. From 2 to negative 2, I am subtracting 4, I'm sorry. And then from 9 to 3, I am subtracting 6. And so that would, and I'm subtracting 4 again from negative 2 to negative 6. From 3 to negative 3, I'm subtracting 6. From negative 6 to negative 10, I'm still subtracting 4. From negative 3 to negative 9, I'm still subtracting 6. So here, they're exactly the same all the way down. And when I calculate my slope, I get my change in y, which is negative 4, over my change in x, which is negative 6. And negative 4 over negative 6 reduces to 2/3. So here we did not end up with a whole number, and that's perfectly okay. This just means that every time y changes by 2, x changes by 3. And the slope here is 2/3. All right, let's look at ordered pairs. This is where we get into using the formula. And if the formula drives you insane, you can always plot these points and count. But for the purposes of what we're doing here, I'm going to show you how to use the formula. So we have our slope formula, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. The sub 2's and sub 1's, they just indicate that those two y's come from two different ordered pairs. So I'm going to plug in negative 3 minus 1 over negative 7 minus negative 2. So I took the y from the second pair and the y from the first pair, and I subtracted them. The y from the second pair is negative 3. The y from the first pair is positive 1. So I'm plugging straight into the formula, negative 3 minus 1. The x from the second pair is negative 7, and the x from the first pair is negative 2. So that's negative 7 minus negative 2. Now when I simplify that, I get negative 4 over negative 5, because negative 7 minus negative 2 becomes negative 7 plus 2. And when I simplify, I get 4/5. Negative divided by negative is positive. And so my slope is 4/5. All right, let's look at another one. I'm going to find the slope of the line that passes through 3, 2, and 5, negative 6. So I'm going to start with my formula. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And I'm going to substitute. Negative 6 is my y sub 2. So I have negative 6 minus 2 because y sub 1 is 2. And then I have x sub 2 is 5. So I have 5 minus 3. And then when I simplify, I get negative 8 over positive 2. And that can be simplified further to just give me negative 4. So here my slope is negative 4. All right. Now, let's look at some special cases where slope is a little different to calculate. We have these lines that the one on the left-hand side would be y equals negative 2. Remember that line is a horizontal line. And the one on the right would be x equals 3. Now, the one on the left, if I try to calculate that using the formula or counting, I see that I don't go up any. My rise, or here my change in y is 0. The y does not change at all. Y is always negative 2. So I just go across 2 units to get to another point. I could have gone across 1 or 3 or 4. And I have that m is, my change in y is 0, so 0 over 2 is 0. So all horizontal lines have a slope of 0. And those are lines that have the form y equals a number. And then I have here my vertical line, and on the vertical line, the y is changing, but the x is not. So I have an up change, and then I have my m, my slope is equal to 4 over 0 in this case, and division by 0 is undefined. So vertical lines have undefined or no slope. We're going to practice with this. So good luck and have fun.